All right, solving rec arrays random. One of the things we do with our constructors, remember, is we always give them the same name as the class. So rec arrays random. The directions to this problem mentioned that there was going to be a single int parameter, and that parameter would be used to initialize the array's length. So we talked about this in class. Very crucial to understand that this array doesn't actually exist until we make it. So line 3 just simply declares the existence of a variable that's capable of holding a rectangle array memory address. Okay, but that's it. It exists. The word new in connection with rectangle bracket bracket, that's what creates the actual rectangle array. Now in my memory of my computer, it's going to have a certain length, and it's going to be given an address, called a reference. That reference is now being held by that variable called rec array. Okay, so now it's ready to be used. What we're going to do at this point is we're going to loop through. We're going to go to every single space in the array. Okay, starting with 0, that's the first index space, all the way across. We could also put rec array.length there. It should be equal to n. And then what we could do this in one line of code or 3 or 4, but we need two random variables. We need a length and a width. Actually, I mean, this doesn't really matter. They're both random, but I think the constructor wanted the width first. Like I said, it doesn't really matter. So I'm going to make two random ints, okay? In both cases, I'm going to use math.random. I'm going to multiply by 10. I'm going to add 1. That's going to give me a range of 1 to 10. You'd have to the instructions. That's where that was specified. And so now we've got our two random values. With those two values, we can construct a rectangle. Okay, you don't have to name it. I'm going to name it R. I could just put it straight into the array as well. If you look in the rectangles class, you'll see that its constructor expects two integers, a width and a length. Okay, that's what I'm giving it. Now that I've got a rectangle, I can go ahead and insert it into my array. My rec array can only hold valid rectangles. All right. R is a valid rectangle reference because I constructed it with rectangles constructor, and now I can put it into the array. If all goes well, I should be able to run my class here and see some rectangles appear in the console. I think it's crucial to pause and run your code frequently so that you check. Okay, don't wait till the end and you might have thousands of error messages and won't be able to untangle them all. But yeah, I went ahead, checked out my constructor. It's looking good. Okay, I'm ready to try some least methods. I'm actually going to write my least diagonal by index method first. And I'm going to show you then how we can kind of use that code throughout their solution. Tracking by index is very useful because you can adapt it to multiple types of situations. So I'm simply going to track where I think this least index is. I have no reason to think that the 0 indexed rectangle has the smallest diagonal. Now, it's kind of a fluke, but in this case, it actually did. That one had an index of diagonal of length of 5, which was smaller than the other 4, but that might not happen again. Okay, if it happens, it happens. If it doesn't, it doesn't. It doesn't really matter because what I'm going to do is I'm going to give every other index in the array a chance to beat this one. Okay, how does it beat it? By having a smaller diagonal. So I can really start this loop at 1, although I've mentioned before, if I started at 0, it really doesn't matter. It's like I've already thought to myself, okay, 0 is the small. So let's go to the next one, and then we'll go to 2, and so on. Okay, let's go all the way across the array. We couldn't use len here, right? It wasn't a parameter, so we have to use the length of the array, I++, and then we're just going to ask a question. So if we go into the rec array, okay, at index I, and we get the length of the diagonal. By the way, in the rectangle class, there's a method just for this purpose called getDiagonal. I mean, I guess technically you could get the length and the width and square root it and stuff, but that would seem kind of silly. So we're just going to go ahead and use this method. If this turns out to be smaller, And I'm going to go back to the rec array. I'm going to apply the same method, get diagonal length, but I'm going to use a different rectangle. I'm going to use the rectangle that is at this index that I'm tracking that I've named least index. If that rectangle's diagonal length, okay, is larger than the one over here, I didn't really have the smallest one. And as a result, I need to update this value that I'm tracking. When I'm finished, I'll have given every index a chance to be labeled as the smallest. And now that I'm finished with these comparisons and my loop ends, then I'm ready to return this index. Now, here's the nice thing about tracking by index, okay? If this works, we could reuse all of this code in our other two methods. So let's go over to the main real quickly, and I'm going to uncomment these three lines, okay? Um, and what I'm going to do, like I said, this is almost cheating in my, but I'm going to paste all this code into here and into here. Now, all right, here's the catch, okay? This method wanted a double. And I mean, technically you could give an int for a double, but the double is supposed to represent not the index, but the diagonal length. Well, here's the thing, right? If you know the index, get the diagonal length from it when you're ready to return. Okay, so I could actually just return. If I knew the index, I could go into the array, get that rectangle, ask for its diagonal length, and then I would be satisfying the return. Or the method said, give me the rectangle. Okay, well, I could do almost that same thing. I just wouldn't even bother to take the diagonal length of it. I would just go back into the array and say, give me the rectangle found there. Remember, the array holds rectangle references. So if the return type of the method says, give me a rectangle, then we can just go into the array and return the rectangle found at that index. There's actually another way we could do this third method. I'll show you in just a second. So of course my replit decides to go put right now. Let's see. All right, let's give it another. And finally, okay. So just looking here, the smallest one, 6.708, and it was at index 2, and it was a 6 by 3. So yeah, looks perfect, okay? All three of those methods work. Now, like I said, there was even a shorter way that we could have done that third one. What we could have done, and I saw at least one group do this, is since we're in this class, we can call this local method and it could go retrieve the index for us. And then we wouldn't even have to bother with all this. This is pretty crazy, but we could actually write a one-line answer right here. I'm just going to let that method that I wrote go get the index for me. And then I'll just return the array found at that index. I could actually do that same thing in the previous method as well. So if you wanted to, you could actually come up here to least diagonal value, and again, just put your method call in here and let it go retrieve that index for you. Okay? And and this would actually work too. So that's pretty crazy. But we could write a one-line answer for both of these methods. And that's again that kind of shows why it's so important to be able to find the index as opposed to the value, as opposed to the object. If you have the index, you can get anything else that you want from there. Okay. So here, my smallest one was actually the first one, 4.44, and you can see it's retrieving that in all three cases. Now, this method here, like I've done on these last one and this first one, that's only going to work if you have a method capable of retrieving that least diagonal index. So, if this was like a quiz and we didn't write that method, then you'd have to kind of revert back to how we did it originally, more of like a standalone method. Okay. But they're both good answers. Okay. As long as you have that method. All right. If we're looking at swap width length, okay, as well as remove small area, and let me just set these up in the main so that we can test these here when we're ready. Okay, so swap width length. Typically, we take 3 lines of code to pull off a swap. The one difference here is we're looking to pull off a swap for every single rectangle. So we're talking about a loop then, which could go through the entire array of rectangles. Now, here's my 3-line swap. Okay, first up, I'll go ahead and grab the width from one of the rectangles. In this case, I've called the rectangle R. And if you go in the rectangle class, there's a method called getWidth. Okay. Now that I have the width, I can overwrite it. The rectangle class, there's also a method called setWidth. And I'm going to set the width to whatever the length of that same rectangle is. Okay. And then I'm going to call, just like that, I'm going to call setLength. Now I've lost the original width in terms of in terms of the rectangle, but I saved it in an integer called W. So that should pull off my swap for me. You could also do like maybe 4 lines of code inside of that loop where you could grab the width and the length and just switch them later. Remove small areas tough. There's no easy way to do this one. Okay, so this is inspired, I mentioned in class, from like previous AP questions. So I didn't put I'm not going to put anything this tough on your first quiz or anything, but by May we want to be able to write code like this. So I'm going to loop through the array, and I'm going to look for keepers. Okay, I want to find the rectangles that have an area that's at least area. Okay, those are the ones that we want to keep. But first up, I'm not really worried about removing anything. I'm just going to count how many there are. With arrays, one of their drawbacks is that we can't change the length of an array. So if I started with 80 rectangles, but I only wanted to keep 50, I have to build a brand new array to do that. Like there's no way for me to just go in there and just remove the ones I don't want. So I've counted how many I want to keep, and I've built a new array to this specific length that I desire. Okay. At this point, what I'm going to do is I'm actually going to loop right back through all the rectangles again. Now, the second time that I look at the rectangles, I'm not going to count them. Now I'm ready to put them into the new array that I'm constructing, assuming that they're keepers, okay, that they've passed this test, that their area is big enough. The problem is my loop right now doesn't have an index. Even if it did, the indexes of this loop wouldn't necessarily match this new array that I'm building. If I started with 50 rectangles, but I was only keeping 20, then the original array would index from 0 to 49, and the new array would index from 0 to 19. So we were going to have a separate index anyway. I'm just going to go ahead and make this index on my own. And instead of like giving its control to the loop, I'm going to control it as I see fit right here. So let me just set this up. We need to brace this so that we can advance the index every time we put something into the array. Okay. Now, even with all this code, and even though I've now created this perfect new array that has, the specified dimension, and it's only got the rectangles in there that I want, unfortunately, I can't really do anything with this array. Remember, when you declare things like int c, int index, int area, and this new rectangle array, they're going to all get destroyed the moment that this method finishes. So once your method calls over, this new array that you just built is wiped out. Well, we don't want it to be wiped out. Often at this point we would return it. That's not an option here because this is a voided return method. We can't return it. Okay. But what we could do is when we built this new array, it was also given space in the memory of your computer, And it was also given a memory address reference as to where you wanted to. Okay. That reference is being held by the variable temp. Variables, okay, whether they're arrays or whatever, they can only hold on to one thing. So it holds on to one memory address, which then leads to multiple rectangles in the memory. But the variable itself only holds one value at a time. So right now, rec array is holding on to a reference and temp is holding on to a reference. We're going to take the reference from temp and give it to rec array. And the way that works is just like we've seen before in Java, things assigned from right to left. So whatever value is being held on the right is going to be assigned to the variable on the left. And what this is going to do is that's going to allow the rectangle array to sort of live on after the method call ends, because we've now taken its address, given it a new home. In this case, rec array. Rec array belongs to the entire class, so it won't get wiped off the memory at the end of our method call. And let's see. It looks like it did run. If you look now, my array now only has 3 rectangles in it, and it actually got rid of the first two, the 3 by 6 and the 7 by 3. Those were deemed too small, so we didn't keep either of those. Okay? Very tough problem. But again, we're going to see things like this on the AP test later.